Okay, now we're going to do a parallel circuit. So in a parallel circuit, there's multiple routes from one side of the battery to the other. On this one, we got 3 different routes. We got 3 different resistors. So that means each resistor acts independently of each other. So if one goes out, the others function normally. Unlike a series circuit where if one goes out, the entire circuit's broken and nothing works. So the first thing we need to do is actually figure out the total resistance or equivalent resistance of this circuit. And for parallel circuits, it means we have to add the inverses of each one. So 1 over RT equals 1 over the first resistor plus 1 over the second resistor plus 1 over the third resistor. And so for this one, that'll be 1 over 6 plus 1 over 12 plus 1 over 4. And when we add those up, we get 1 over 2. But that's not the total resistance, that's the inverse of it. So we have to take the inverse one more time. So the total resistance of this circuit is 2 ohms, yes. One thing that you can check is, in a parallel circuit, the total resistance is always less than the smallest resistor. Our smallest resistor was 4 ohms, so I know the total resistance of this circuit has to be less than 4 ohms. Now after we found the total resistance, we need to find the total current. We still use Ohm's law, V equals IR, voltage 24, current we don't know, resistance is 2 ohms. So we get 12 amps is our total current. So that's the current that leaves the battery is 12 amps. But since it's a parallel circuit, that current breaks off and goes to different resistors. So we need to find the individual resistance of each one. But one of the properties of a parallel circuit is that the voltage is the same for everything. In a series circuit, it was the current that stayed the same every place. But a parallel circuit is the voltage that stays the same. So each one of these resistors gets 24 volts from the battery. So each one has the same potential difference across it. For current, though, that's what we have to find. And we're going to use Ohm's law again. So that first resistor gets 4 amps of current of the 12 amps that comes from the battery. The second resistor gets 2 amps. And the last one gets 6 amps. And we can check our answer right now because we add up all the individual currents. 6 plus 4, 10, plus another 2, 12 amps. If we add up all those, it should equal the total current from the battery, which it does, so we're fairly confident in our answer. Now for power, we find it just like normal. We're going to use the power equation. Total current, 12 amps. Voltage, 24 volts. So the total power of this circuit, go to the calculator, 24 times 12, 288 watts of power. Now we can find the individual powers as well. And for that, we're going to use the individual values for current and voltage for each resistor. The current through the first one, 4 amps. Voltage, 24 volts. (96 watts. Same thing for the second one. We got a current of 2 amps, voltage 24 volts. .48 watts for the second one. And the last one, power, current times voltage. Current is 6, voltage is 24. So 144 watts of power for the third one. And here's another neat little check. If we add those up, 144 plus 48 plus 96, we get 288 watts, which is the total power of our circuit. So that's another way that you can check and look at your answers. Okay? Thank you very much. Talk to you later. Bye.